guys, we're going to start today's notes on inverse trig by first reviewing the trig that we did in yesterday's notes. So we're first going to talk about what those trig ratios are again. So a sine would be opposite over hypotenuse. And we use SOH, that acronym, okay, for the sine opposite hypotenuse. And then for our cosine, that was adjacent over hypotenuse. So we use CAH. And then for our tangent, that was opposite over adjacent. So that's TOA. All right, let's review entering these into our calculator, making sure we've got the correct mode if we are using a graphing calculator. So we're going to look at the tangent of 22 degrees. So go ahead and type in the tangent of 22 degrees into your calculator. Try the sine of 34 degrees. And then the cosine of 79 degrees. And for each one of those, you want to round to the nearest hundredth. So that's 2 decimal places. Let me bring up my calculator and look at all 3 of those. So tangent of 22 degrees, sine of 34 degrees, and then the cosine of 79 degrees. Okay, so it looks like we've got 0.40, 0.56, and then 0.19. Okay, if you are not getting those answers, then we need to check something on your calculator, and you can send me a message and we can talk about that. All right, so we said 0.40, 0.56, and 0.19. All right, so then we're going to put those 2 things together and review solving for a missing side. All right, so what we did here on yesterday's notes is we took a look at our angle and we labeled which sides we had from the perspective. So for 32 degrees, x is the opposite side, and 46 is the hypotenuse. And for letter B, from 41 degrees, 12 is the adjacent side, and x is the hypotenuse. Okay, so remembering what our 3 trig functions are, for number 3, this is opposite and hypotenuse. That would be sine. So the sine of 32 degrees, opposite over hypotenuse. So to get x alone, we need to multiply both sides by 46. So we will type in 46 times the sine of 32 degrees to equal x. Go back to our calculator. 46 times the sine 32. And what we get is 24.3, and that'll go up to 8. 24.38. 24.38. All right, and then looking at part B. So this one has adjacent and hypotenuse. That's cosine. So cosine of 41 degrees, adjacent over hypotenuse. So when your variable is in the denominator, the shortcut that we use is to switch the x and the cosine of 41, because you will end up dividing by that trig function in order to get x alone. So we're going to do 12 divided by the cosine of 41. 12 divided by cosine 41. and that's 15.90 stays 0. So x is 15.90. That 5, make that look nice. Okay, so that's just a quick review on solving with trig ratios from our previous notes. Today's notes are going to talk about what we do when our x is in a different spot than we've seen it in previously. So number 4 is asking what's the difference between these two equations. So the first one is something that we've already been working on. This is what you just did in part A of number 3. This is when you are looking for a side. So if you have your x as part of your ratio, this is the unknown side. Right, so this is the piece that's unknown. But in the second equation, your x is attached to the angle, or is attached to the sign. That means that it's the missing angle. So the difference here is in the second equation, we don't know what the angle measure is. Okay, so that's what we're going to concentrate on today. When we're solving for a missing angle, we've got to do something a little bit different. And what that thing is inverse trig function. So instead of just using sine, cosine, and tangent, we're going to use what is an inverse sine, inverse cosine, and inverse tangent. So where will we find that? Here's an example, a little screenshot of a graphing calculator. And if you want to use an inverse trig function, you will see that written above your sine, your cosine, and your tangent keys. So if you are using a graphing calculator, you will need to hit that second key first, then hit the sine in order to access the inverse. If you are using a scientific calculator, I think you hit the shift key first and then hit your sine, your cosine, or tangent to access those inverse keys. Okay, so inverse trig functions are what we use when we are looking for a missing angle. All right, so let's practice first with the calculator for each one of these in number 5. So what we'll do, I'm going to show you how you enter it into your calculator. So if we are looking for the angle measure A, we will say measure of angle A will be the inverse tangent of whatever. Okay, I'm just going to work with it. So C, we are looking for the measure of angle C. So to separate the from the angle, we use an inverse. Okay, and then looking at part B, we get angle A alone, the measure of angle B. Use the inverse of the number that is given. Okay, so that's how you separate a trig function from an angle. You use an inverse. So what we're going to do now is we're going to type those into the calculator and then come up with what that angle measure is. When we are talking about angle measures, we round to 1 decimal place, okay, the nearest tenth. If we do sides, which is what we've done previously, we do 2 decimal places. But if you're talking about an angle, you use 1 decimal place. All right, so let's go to the calculator, and I want you to try this in your calculator as well. Okay, so the first one was the inverse tangent. So hit your second or your shift key, tangent. So make sure you've got that little -1 after your tangent. And then you're going to type in 28.6363. Okay, so this is part A. Rounded to the nearest tenth. So 1 decimal place would still be 88. And then let's look at part C. Part C was an inverse sine. So second sine. And then this is 0.0 1045. Close it. Enter. Okay, so if we're rounding to 1 decimal place, this is 0.99. So this is going to move this up to 6. Okay, so instead of 0.599, it's going to become just 6.0. And then the third one, second cosine of 0.6584. Close. This one to 1 decimal place is 48.8. Okay, and each of those are in degrees. So just make sure that you're checking your calculator with the answers that we have here so that you know you're entering them in correctly. All right, let's go back to the notes and fill in those answers. So for A, we got 88 degrees. When we rounded to 1 decimal place, you could do 88.0 if you wanted. For part C, we had 6 degrees. You could put 6.0 if you like. And then for part E, we had 48.8 degrees. Okay, what I would like you to do right now is I'd like you to do B, D, and F. So pause the video, write down what it is you would type into your calculator, type it in, and then record your answers. Unpause the video as soon as you've got all 3 of these done so you can check to see if you're correct. Okay, let's check your answers and see how you did. In green, you can see that I rewrote the angle separated from the trig function. And then what we would do to find that answer would be to use inverse trig. And then what you can see in blue are the answers after I have rounded to 1 decimal place. Okay, so let me flip over to my calculator so you can see those 3 answers. So for the cosine, 20.99 is going to be rounded to 21. For the tangent, inverse tangent, 49.00 is going to raise to, or it's going to leave that at 49. And 72.08, that 8 is going to make that 0 go up to a 1. So that's where the 72.1 came from. Okay, so let's put this into use now in solving for a missing angle in a right triangle. So in number 6, we're going to start the same way we solved when we were solving for a missing angle. So you've got x as our missing side. Here's your angle. From this angle, 6 is opposite side, and 15 is hypotenuse. So remembering our sine is opposite hypotenuse, cosine adjacent hypotenuse, and tangent opposite adjacent. So O and H would be sine. So sine of my angle, which is x, is my opposite side over my hypotenuse. Okay, now in order to separate the x from the sine, we do an inverse. So the inverse sine of, instead of a decimal, we've got this fraction, 6 over 15, and that equals x. Okay, if you wanted to reduce your fraction first, you could. You don't have to. But entering in the inverse sine of 2/5 will get you the exact same answer. All right, so let's go to our calculator, and we are doing inverse sine of 6 over 15. Okay, so 23.1 decimal place for an angle. This will be 23.6. So x is 23.6 degrees. All right, let's do that again on number 7. From this angle, 400 is our opposite side, and 300 is our adjacent side. So O and A are tangent. So tangent of x is 400 over 300, opposite over adjacent. So we do an inverse of 400 over 300 will give us our angle measure. Or again, if you wanted to reduce that before you put it into your calculator, you certainly could, but it's not necessary. you'll get the same answer either way. So inverse tangent of 400 over 300. Rounded to 1 decimal place would be 53.1 degrees. So our missing angle is 53.1 degrees for number 7. All right, last one, number 8. So from this angle, 6 is the adjacent side and 9 is the hypotenuse. So A and H are cosine. So cosine of x adjacent over hypotenuse. In order to separate x from the cosine, we're doing an inverse. If you want to reduce that before you enter it, go ahead. You would get 2/3. That's what you're taking the inverse cosine of. But again, your answer is the same either way. So you do whatever is more comfortable for you. So second cosine, 6 divided by 9 would be 48.1. This is an 8, which makes that go up to a 2. So 48.2 degrees. 48.2 degrees. Okay, that does it for inverse trig. So now on your homework, I can put the value of x as an angle or as a side, and you should be able to solve for that missing piece. Okay, so go ahead and move on to your homework, and I hope you have a great day. Bye.